The Cosmic Tapestry. A Tale of the Sun. In the vast, unimaginable expanse of nothingness, a singularity existed, a point of infinite density and heat. Then, in an event beyond comprehension, the singularity burst forth in the Big Bang. This wasn't an explosion in space, but rather the explosive creation of space itself, along with time and all the fundamental particles that would form the universe. The first stars ignite. The universe expanded and cooled. Protons and neutrons fused to form the lightest elements, hydrogen and helium. Gravity, the architect of the cosmos, began to pull together vast clouds of these gases. Within these clouds, denser regions began to collapse under their own gravity, heating up as they contracted. These were the birthplaces of the first stars. Our stellar nursery. Our sun wasn't among the first stars. It formed much later, within a swirling cloud of gas and dust left over from previous generations of stars. This cloud, known as a solar nebula, was enriched with heavier elements forged in the cores of those earlier stars. A nearby supernova, the explosive death of a massive star, likely triggered the collapse of this nebula, sending shockwaves through it. The protostar awakens. The solar nebula began to spin faster and faster as it contracted, flattening into a disk. At the center of this disk, a dense ball of gas formed, a protostar. This protostar continued to accrete matter from the surrounding disk, growing hotter and denser. Nuclear fusion ignites. Eventually, the core of the protostar became so hot and dense that nuclear fusion ignited. Hydrogen atoms began to fuse together, forming helium and releasing tremendous amounts of energy. A star was born. Our sun. This event, known as ignition, marked the beginning of the sun's main sequence phase, the longest and most stable period in a star's life. The main sequence. A stable star. The sun has been shining steadily for about 4.6 billion years, powered by the fusion of hydrogen in its core. It's currently a yellow dwarf star, comfortably nestled in the middle of its main sequence lifespan. This phase is characterized by a balance between the outward pressure from nuclear fusion and the inward pull of gravity. The future. Red giant and beyond. In about 5 billion years, the sun will begin to run out of hydrogen in its core. It will then expand dramatically, becoming a red giant. Its outer layers will swell, engulfing Mercury, Venus, and possibly Earth. Eventually, the sun will shed its outer layers, forming a beautiful planetary nebula. The core will then contract into a dense, hot white dwarf, which will slowly cool and fade away over billions of years. Our sun's current location on the timeline. To illustrate the sun's current location on the timeline, imagine a line representing its entire lifespan. Big Bang, first stars, solar nebula, protostar, ignition, main sequence, now, red giant, planetary nebula, white dwarf, black dwarf, hypothetical. To complete the timeline, you would add the following labels. Big Bang. The origin of the universe. First stars, the earliest stars formed from hydrogen and helium. Solar nebula, the cloud of gas and dust that formed our solar system. Protostar, the early stage of the sun before nuclear fusion began. Ignition. The moment nuclear fusion started, marking the birth of the sun. Main sequence, current stage, where the sun fuses hydrogen into helium. Red giant, the future stage where the sun expands and cools. Planetary nebula, ejected outer layers of the sun. White dwarf, the hot, dense remnant of the sun's core. Black dwarf, hypothetical, cooled, faded remnant of a white dwarf not yet observed. This story of the sun, from the Big Bang to its eventual demise, is a testament to the grand and ever-evolving nature of the universe. It's a reminder that we are all part of a cosmic tapestry, woven from the remnants of stars and the echoes of the Big Bang.